Good morning to all of you. Today I am going to explain that new chapter alcohol. Alcohol is an organic compound that carries at least one hydroxyl functional group bonded to a saturated carbon atom. The term alcohol originally referred to the primary alcohol ethanol, which is used as a drug, is the main alcohol present in alcoholic beverages. An important class of alcohol, of which methanol and ethanol are simplest member, includes all compounds for which the general formula CnH2n plus 1OH. Simple monoalcohols that are primary are CH2OH, secondary R2CHOH, and tertiary R3COH alcohol. The suffix OL appears in the IUPAC chemical name of the substance where the hydroxyl group is the functional group with the highest priority. When a higher priority group is present in the compound, the prefix hydroxyl is used in its IUPAC name. The suffix ol in non-IUPAC name such as a paracetamol or a cholesterol also typically indicates that the substance is an alcohol. However, many substances that contain hydroxyl functional group, particularly sugar such as glucose and sucrose, have names which include neither the suffix ol nor the prefix hydroxy. The nomenclature IUPAC system is used in sufficient publication and where precise identification of the substance is important, especially in case where the relative complexity of the molecule does not make such a systemic name unwidely. In naming system alcohol, the name of the alkene chain loses the terminal E and adds the suffix ol, that is ethanol, from the alkene chain name ethane. When necessary, the position of the hydroxyl group is indicated by the number between the alkene name and the oil. Propane OL, 1OL, or CH3CH2CH2OH, propane 2-ol for CH3CHOH, If a higher priority group is present, such as an aldehyde, ketone, or carboxylic acid, then the prefix hydroxy is used. For example, as in 1-hydroxy 2-propanone, CH3COCH2OH. Then, in other less formal context, an alcohol is often called with the name of the corresponding alkyl group followed by the word alcohol. Example: methyl alcohol, ethyl alcohol, propyl alcohol, maybe N-propyl alcohol or isopropyl alcohol, depending upon the hydroxyl group is bonded to the end or middle carbon on the straight propane chain. As described under the systemic naming, if another group of the molecule take priority, the alcohol moiety is often indicated using the hydroxy prefix. Then another name system is there, that is your common name system. In common name system, alcohol can be named as derivative of methanol using carbonyl as the ending. For instance, CH3 whole thrice COH can be termed as trimethyl carbonyl. Then physical property of alcohol. In general, the hydroxyl group makes alcohol polar. This group can form hydrogen bond to one another and to most other compounds. Owing to the presence of polar hydroxyl group are more water soluble than simple hydrocarbon. Methanol, ethanol, and propanol are miscible in water, whereas the butanol with the 4 carbon chain is moderately soluble. Because of hydrogen bonding, alcohol tend to higher boiling point than comparable hydrocarbon and ethers. The boiling point of the alcohol, that is ethanol, is 78.29 degrees C compared to the 69 degrees C for the hydrocarbon hexane and 34.6 degrees C for the diethyl ether. The next point is that the method of preparation. There is a different types of method of preparation is there. So that first method is hydrolysis of alkyl halide. So hydrolysis of alkyl halide, this is also the nucleophilic substitution reaction. The method is not a very effective one. This is because it has a olefin as byproducts. So that a reaction alkyl halide, that is Rx, when treated with alcoholic KOH, so it will give ROH plus KX, where R is the alkyl group and X is the halide group for like chlorine, fluorine, bromine, etc. The next method, hydration of alkene. In the preparation of alcohol from alkenes, it is possible to form two different alcohols. For example, that is alkene CH3CH double bond CH2, that is propene. When treated with water, that is, it will give one propanol and two propanol, whereas one propanol is the minor product and two propanol is the major product. According to the Markovnikov's rule, we know that when a unsaturated alkene treated with unsaturated reagent, then the positive part of the reagent should be attached to the double bonded carbon atom, which carries the maximum number of hydrogen. So here this double bonded carbon atom, that is carbon number 1 carries 2 hydrogen, carbon number 2 carries 1 hydrogen, so that after ionization of water it will give H plus ion and OH minus ion. This H plus ion should be attached to the double bonded carbon atom, that is that carbon number 1 carries 2 hydrogen, that's why it will give 2 propanol as the major product. Then the next method, preparation of alcohol from the Grignard reagent. As we know that the Grignard reagent, composition of Grignard reagent, that is methyl magnesium iodide, or maybe that is alkyl magnesium iodide. So how we'll get the Grignard reagent, that is alkyl iodide when treated with, or alkyl halide treated with magnesium in presence of ethanol to give that in presence of ether, dry ether, it will give alkyl magnesium halide. So then this alkyl magnesium Grignard reagent has the general formula RMgX and the general name alkyl magnesium halide. When what class of alcohol we obtain from the Grignard synthesis depend upon the type of carbonyl compound that we used in the reaction. In case of formaldehyde, it will give that primary alcohol. When it will use that aldehyde, gives that secondary alcohol. And while use that ketone, it will give tertiary alcohol. So the next method, reduction of carbonyl compounds. We can also get that alcohol by reduction of aldehyde and ketones. We can reduce aldehydes to primary alcohol in presence of lithium aluminum hydride, for example CH3CHO. Methyl aldehyde, when treated with lithium aluminum hydride, it will give that CH3CH2OH. And ketone to give that secondary alcohol. For example, that is acetone CH3COCH3 in presence of lithium aluminium hydride, it will give secondary alcohol, that is CH3CHOH CH3. This process can take place by the catalytic hydrogenation or by the use of calcium, used by the chemical reducing agent like lithium aluminum hydride. The next another one method is there, that is action of nitrous acid on primary amine. That is primary amine, when treated with nitrous acid HNO2, it will give ROH plus nitrogen plus water. And another last method, that is reduction of acid to alcohol. Lithium aluminium hydride, that is LiAlH4, is one of the few reagents that can reduce an acid to an alcohol. That is, for example, RCOH, when treated with lithium aluminium hydride, it will give RCH2OH, that means the primary alcohol, because of the excellent yield it gives. Lithium aluminum hydride is a common ingredient in the laboratory for the reduction of not only acid but many other classes of compound. So then this all about that method of preparation for alcohol. Then the next another thing is there, that is a reaction of alcohol. So first point is that dehydration of alcohol. Dehydration of alcohol means elimination of water from that alcohol to get that alkenes. When that alcohol treated with sulfuric acid, it will give CH2 double bond CH2, that means alkene along with water molecules. Then oxidation of alcohol. This is the very important reaction, because in organic chemistry oxidation means we know that addition of water and or addition of oxygen or removal of hydrogen, and a reduction means addition of hydrogen or removal of oxygen. In the oxidation of an alcohol, two hydrogen atoms are removed from the alcohol. One hydrogen comes from hydroxyl group and the other comes from the carbon bonded to the hydroxyl group. Many different oxidizing agents such as potassium permanganate and potassium dichromate can be used. Different kind of carbonyl compounds are formed depending upon the structure of the alcohol and the reaction condition. So the primary alcohol are converted into the aldehydes if carefully controlled conditions are used, or into aldehyde and a carboxylic acid if an excess of oxidant is used. Secondary alcohol are converted into ketone on the treatment with oxidizing agent. And tertiary alcohol do not give any reaction with oxidizing agent because they do not have hydrogen on the carbon atom to which the hydroxyl group is attached. Then some chemical test for alcohol. Any of the following tests can be carried out to detect the alcoholic functional group, like sodium metal test, star test, then steric ammonium nitrate test, acetyl chloride test, and iodoform test. So first one, sodium metal test. It is based on the appearance of brisk effervescence due to the liberation of hydrogen gas when the alcohol react with active metal like sodium. For example, that is the reaction. So ROH, that is alcohol, when treated with sodium metal, it will give sodium salt of alcohol plus hydrogen gas. Then next another one test, that is your star test. Carboxylic acid react with alcohol, form a fruit smelling star. The reaction between an alcohol and a carboxylic acid is called starification. This reaction is a slow reaction catalyzed by concentrated sulfuric acid. The chemical reaction is a given below, that is alcohol ROH plus acid RCOH. When treated both of them, it will give star, that is RCOOR plus water. For example, one compound, that is methanol, when treated with acetic acid, it will give CH3 COO CH3 plus water. So then next another method is there, steric ammonium nitrate test. Alcohol or reaction with steric ammonium nitrate forms a pink or red color precipitate due to the formation of a complex compound and ammonium nitrate. So then next another method is there, that is acetyl chloride test. Alcohol react with acetyl chloride, result in the formation of ester and hydrogen chloride. The resulting hydrogen chloride on contact with ammonium hydroxide forms a white fumes of the ammonium chloride and water. That reaction ROH, that is alcohol, plus acetyl chloride CH3COCl, so it will give CH3COOR, that is the ester plus hydrochloric acid. Then HCl treated with ammonium hydroxide NH4OH, it will give ammonium chloride plus H2O, that is ammonium hydroxide forms white fumes. So that means during the formation of ammonium chloride NH4Cl, so that's why some white fumes will produce. It indicate that that compound is your alcohol. Then iodoform test. This test is given by the secondary alcohol, ketone and acetaldehyde. First, the compound is heated with the sodium hydroxide solution and iodine. A formation of yellow precipitate of iodoform shows the presence of alcohol. So first that reaction CH3CHOH, that is the secondary alcohol, when treated with iodine plus sodium hydroxide, it will give ketone, that is acetone CH3COCH3, then plus sodium iodide plus water. Then acetone, when treated with iodine plus sodium hydroxide, also it will give new compound iodoform. That's why it will give that yellow color precipitate. It means, it indicates that that compound is alcohol. So next, how we will distinguish that primary, secondary and tertiary alcohol by taste. So they are having some specific taste. So first one is the Lucas test. So Lucas test, by this Lucas test we can easily identify, we can easily distinguish that primary, secondary and tertiary alcohol from that a mixture. So this Lucas reagent, that is the mixture of zinc chloride ZnCl2 and concentrated hydrochloric acid, is called as Lucas reagent. It reacts with primary, secondary and tertiary alcohols at different rates. This reagent forms a cloudiness on reacting with alcohol. Tertiary alcohol react immediately and gives cloudiness. Secondary alcohol reacts slowly and gives cloudiness after 5 to 10 minutes, and there is no reaction with primary alcohol. So by this reaction only we can easily identify, we can easily distinguish that primary, secondary and tertiary alcohol. That means that cloudiness appears immediately. If that cloudiness appears immediately, it indicates that that alcohol is tertiary alcohol. If cloudiness appears within 5 to 10 minutes, it indicates that that alcohol is secondary alcohol. And cloudiness appears only on heating, that means it indicates that alcohol is the primary alcohol. Then next another one test is there, that is dichromate test. Dichromate test is solution of sodium dichromate. Sodium dichromate Na2Cr2O7 is known as dichromate reagent. It reacts with primary, secondary and tertiary alcohol in different rates. This red reagent forms a cloudiness on the reacting with alcohol. That is, so the primary alcohol react immediately and gives cloudiness. Secondary alcohol reacts slowly, gives cloudiness after 5 to 10 minutes, and tertiary alcohol there is a no reaction with dichromate reagent. It indicates that this by this dichromate test or maybe that Lucas test we can easily identify that alcohol is the primary, secondary or tertiary alcohol. Thank you.